Hey everyone. Welcome back to Masterpiece Delta. Today, we're going to talk about a common but important tool in a lab that helps scientists and students understand the periodic elements. It might look like a bunch of boxes with symbols, numbers, and letters, but it's way more awesome than it seems. Let's start with the periodic table and put the actual elements for the last in this video. The periodic table is a big chart that shows us all the elements in the world. What is an element? An element is a basic building block of everything. You, me, water, air, trees, even your pencil. All made of elements. There are 108 elements. And all elements have a special name, number, and symbol. From hydrogen to element 118. In 1869, a scientist named Dmitry Mendeleev made the first version of the now common periodic table. He grouped elements that acted the same together, had similar properties and physical forms, and even guessed some that had not been found yet. This is how we read the periodic table properly. Rows left to right are called periods. Also a groundwork for orbitals. Columns up and down are called groups, or families. Each box shows the name, symbol, and atomic number of an element, and also its properties. Now, if you're overwhelmed by the fact that there are 108 elements, and if your brain is about to blow up, there is no need to worry, I can visualize it all. We start with the first of the two, alkali and alkaline earths. Those two groups form hydrogen and a ton of heat when produced, and form strong bases, like sodium hydroxide. The only element that is not like those two is included in the first group, hydrogen. Transition metals are the biggest group in the periodic table, and most elements are very useful there. Iron, gold, platinum, tungsten, and so on. And now, the halogens, a group of noxious and poisonous elements, but very important like the other groups, chlorine, iodine, and so on, are characterized by their odor and their tendency to react with basically anything. Because they have 7 electrons on their last orbital. And once they form a compound, it's very stable, meaning it's very hard to decompose or disassociate. One noteworthy example is Teflon. The noble elements, or gases, are a group of 8 exceptionally inactive elements. And back then, in the early days of modern science, scientists believed they were incapable of forming a compound until some compounds of xenon and fluorine were made. 6 elements: oxygen, nitrogen, carbon, phosphorus, hydrogen, and sulfur, are called the pillars of life. And it's easy to see why. Without them, there is no life on Earth. Now the actinides and the lanthanides are the two last groups that are radioactive in nature. Both natural and synthetic. Like uranium and thorium, plutonium and americium. Radioactive in nature. They are used in nuclear reactors and even bombs. Like Fat Man, which is plutonium-based. Or Little Boy, which is uranium-based. 2 of the first atomic bombs used in a war. A note of necessary advice. Radiation is no joke. It can kill by unraveling the cell's blueprints and instructions. DNA. Cancer and catastrophic organ failure follow after a human absorbs a lethal dose of radiation. One such unfortunate victim is Hisashi Aoki, who died the most painful radiation-based death ever recorded and lived for 83 days before passing away. Who received a staggering 17 sieverts, SV. A guaranteed death sentence, for comparison. 4 to 5 sieverts is the standard lethal dose. A noteworthy subclass, called super-heavy elements. These elements start at element 104. All are synthetic and have exotic names. All are characterized as unstable. And the heaviest ones have a half-life of only minutes to nanoseconds. Before this video ends, make sure to click the bell button, activate notifications, and click like. Also, leave a comment down below and share this video. See you next time.